to the challenge. This is Michael Goodman.
And Celine Dalday.
Today we'll be discussing the physics of swimming. In our experiment, we measured how acceleration in swimming relates to 3 different hand positions: open, relaxed, and closed. This relates to physics because we were able to calculate the force of each hand position because we measured the time at 1 meter intervals for 10 meters.
We had Lucy swim 5 times for each hand position, and just from knowing the times, we were able to average the data to find force, kinetic energy, work, acceleration, and velocity.
Newton's second law can be applied to our experiment with the swimmer's hand positions.
The force can be found by using the equation force equals mass times acceleration.
Therefore, we can compare the forces that each hand position is applied to the water.
Newton's third law also applies to swimming. Every action has an equal or opposite reaction.
When you apply a force to the water pushes back, and you are propelled forward.
Each hand position applies a different amount of force to the water, so the water pushes back with that same amount of force.
Therefore, the speed changes depending on the hand position.
Through this experiment, we have evidence that the kinetic energy is equal to the amount of work applied.
Lucy has kinetic energy because she is in motion.
Lucy is doing work on the water because she moves a distance while she applies a force.
The work can be calculated by doing the equation 1/2 mass times the final velocity squared minus the 1/2 the mass times the initial velocity squared.
This is also equal to the change in kinetic energy, and since the kinetic energy does not change due to the conservation of energy, the work is the same as the kinetic energy.
So I think that wraps up our video presentation. Signing off, this is Lucy Schroeder.
Michael Goodman.
And Celine Dalday.
And Amelia Gray.